Complex networks. Application of complex networks for cooperative engagements capability by Jorge D. Moreno. Instructor's name, Dr. Mihalik. The purpose of this presentation is to give an overview of the application of complex networks for cooperative engagements capability. So what is a network? Is the allocation of intersecting horizontal and vertical lines and can also be interpreted as a group of interconnected things or people. So what is a complex network? It's a network or graph with non-trivial topological features. A network can be interpreted as a series of nodes interconnected by communication paths. It can also be interpreted as entities that are interconnected with links or paths, such as friends, computers that are linked together, and web pages or domains that point to each other. A complex network can be interpreted as real-life large graphs. For example, social networks, technological networks, and biological networks are examples of complex networks. Here are more examples of complex networks, and these are semi-geometric networks. A complex network, it can be a brain, the regular nodes are neurons, and the regular edges at synapses. The internet, it can be another complex network. Routers are irregular nodes, and wires are the regular edges. Geometric complex networks, an example can be the traffic. The regular nodes are cars, and the regular edges are perceptions. Another example of a geometric complex network can be insect colonies, and the regular nodes are termites, and the regular edges are pheromone. More examples of complex networks with node diversity and node state dynamics. An example, as I mentioned before, of a complex network is the internet. The node diversity can be routers, switches, or PCs. The node state dynamics can be routing state or algorithms. Gene regulation can be another complex network, another example of a complex network. The node diversity can be the protein type or the DNA sites. The node state dynamics can be boundless or concentration. More examples of complex networks with edge diversity and edge state dynamics. Gene regulation, it can be a complex network. The edge diversity can be blocking and enhancing, and the edge state dynamics can be mutations and evolution. Characterization of complex networks. The characterization of complex networks identifies the diameter, clustering coefficient, degree distribution between centrality, which are number of paths going through a vertex, communities, correlations between degree and other quantities, local motifs. Motifs are subgraphs that have a significantly higher density in the observed network than in the randomization of the same, and assortability. The distribution of a complex network is a key factor when studying real and random networks, such as social networks and internet. The Bernoulli model, named after Swiss Jacob Bernoulli, which is the simplest network model, has a binomial distribution. The nodes are connected with independent probability of degrees. This model can be interpreted as P times K equals parenthesis n minus 1 over k close parentheses p to the power of k parentheses 1 minus p close parentheses to the power of n minus 1 minus k. N equals nodes, p equals independent probability, and k equals binomial distribution of degrees. The cooperative engagement capability. In the U.S. Navy system, The capability of an application complex networks for cooperative engagement is crucial for the protection and safe environment of the United States of America. Their cooperative engagement capability has two major system functions that consist of a cooperative engagement processor for sensor networking and a data distribution system that is used for real-time communications. The system communicates with the platform sensors and combat equipment platforms. The complex network system allows to take full advantage of the diversities that each combatant provides at different locations with different sensors and weapons frequencies. The Internet and World Wide Web. The Internet is a network of routers that transmit data among computers. These routers are grouped into domains, which are connected to map the connections. The trace route utilities are used to send test data packets and trace their paths. The connectivity degree of a node follows the power of its rank, and the most connected nodes are the ones that are least frequent. In short terms, the Internet is a scale-free network. The World Wide Web. The World Wide Web is a network of documents that reference each other. In the World Wide Web, the nodes are the pages and the edges are the hyperlinks. The edges are directed. They can be outgoing and incoming hyperlinks. www, which is World Wide Web, is a scale-free network and is also a small world. Complex networks are used in our daily life to facilitate the things we do every day. Social networks, technological networks, biological networks, and many more are suitable to maintain a cooperative engagement capability to enhance productivity in our lives, our work, our relationships, and so on. Thank you for watching this presentation. My name is Jorge D. Moreno, and my instructor's name is Dr. Mahalik. Thank you.